Ahoy! 8.1 is about graphing f of x equals a times x squared. The little square here is not a square. I don't know why it's not showing up. Anyway, here it is. There's a lot of vocab that you're going to get used to for this chapter. So quadratic functions are what we've been dealing with. It's anytime you have x squared, it's going to make a quadratic function. And when you graph it, it makes a little U shape, which is called a parabola. The bottom or the top of that parabola is called the vertex. And then there's an axis of symmetry that goes right through the vertex. It's the point where you could fold the parabola over and it would match up. And then other words we've talked about, which we're going to use a lot in this chapter: domain, range, and then we've talked about vertical shrinking, vertical stretching, and reflections. So that's a lot of what we're going to be doing for this chapter. So here's what you should add to your notes for 8.1. I would not copy this word for word. What I would do is read this over and then add into your notes what you feel is the most important key points. Definitely, I would include the words parabola. I would explain that a quadratic function is anything that has that form right there. And it makes this parabola that has a vertex. When it's going down towards the vertex, that's decreasing, and going up away from the vertex is increasing, unless, of course, it's upside down. And then the line that goes right through the vertex is the axis of symmetry. So there we go. Take some great notes. And now let's jump into this parabola right here. So this is a graph of a quadratic function. So you can identify the characteristics like the vertex, the axis of symmetry, and so on here. So looking at this, where would the vertex be? Where is the vertex? Okay, yeah, if you pointed to this point right here, which is -1, -2, that is the vertex. There it is. Look at that. Fantastic. The axis of symmetry is x equals -1. It goes right through the vertex. This is the point where if you fold it over, the parabola matches up. And then these two are the roots or the zeros, which we've done already in the last chapter. That's factoring to get those. But they're not talking about that for this problem. But it is mentioning that the domain is all real numbers. You can plug in any value for x. The range, however, is bigger than or equal to -2. All of your values for your outputs, all your y values, are only going up from -2, which is the lowest point. So there we go. Great example. Oh yeah, and the increasing, decreasing. So the function is decreasing as x approaches -1, and it's from the left here, and it's increasing as it goes away from -1. All right, so that was that. Now let's add some more notes. Woo! So if you're graphing a times x squared, a is your coefficient. When a is bigger than 1, it goes like it's vertically stretched, so it gets skinnier. And when a is less than, here it is. When a is between 0 and 1, it flattens out, gets flatter. When a equals 0, you get a horizontal line, because that makes a linear thing. And then when a is negative, it decreases. So this is a great thing to add into your notes. And now we got some questions to actually ask, now that you've added a bunch to your notes. So here we go. So if you're going to graph this, let's say that x is 0. What is f of 0? Okay, so in both of these, if you're going to graph this one or this one, you're going to get 0. So 0, 0 is a value for both of these graphs. So g of x has a 0, 0. F of x has 0, 0. Now, you can either graph these out or just kind of mentally picture in your head. Which of these is going to be skinnier, like vertically stretched? Is that f of x or g of x? Okay. If you said g of x is skinnier, you're right. And here's why. You can make a table of values and see that there's your g of x for those different values of x. And then if you did f of x, it would look like that, which is just x squared. So the 2 there makes it vertically stretched, makes it look skinnier. It's narrower. All right, so that's a great example. Feel free to add that to your notes if you want. You don't have to add that one. All right, so this one, this negative 1/3, that's not only going to flip the graph over to make it upside down U shape, but the 1/3, is that going to make it narrower or wider, the 1/3 part? Yeah, the 1/3 is going to make it wider. It like flattens it out. So the negative 1/3 x squared is going to be flatter and upside down. You can get the values by plugging in different values for x. They're using these values because it gives you nice whole numbers. I mean, you can use like -2, -1, 0, 1, and 2. That's great. But it's good to make use numbers that give you whole number answers if you're graphing. So you can plot that, and you'll get an upside down. There we go. Look at that. And comparing that to just the f of x equals x squared, the 1/3 is a little flatter. It's a little wider, and it's upside down. Okay, there we go. And then the last example is a real life example. So here we have a satellite dish. This is the equation for the satellite dish. I'll just ask you an easy question. What's the vertex? Yeah, the vertex is 0, 0. That's the bottom point. And then it says to find the width and depth of the dish. Well, we can see it right here on this graph. Notice they're numbering by halves. So like that's a half, that's 1, 1.5, and 2, and so on. So if it wants the width and the depth, you can make the graph, and then you will see, oh, here, the domain. Are they talking about domain? They are, yes. So the domain is between -2 and 2. That's the x values, because we don't need our dish to go past that. And then the range is going from 0 to 1. So therefore, the height is 1 meter, or the depth of the dish. And the width of the dish is a total of 4 meters. It's from -2 to +2. So you will have some like real life examples, but all of them are going to use a standard f of x equals a times b to the, or ax squared form. Okay, if you have questions while you're working through this, let me know, and I will be happy to help, and I will see you in class. All right.